various industries, which are process industries, oil and gas, manufacturing, etc. This is very much applicable to that. One of the things that we have been looking at over the past 10, 15 years, I started my career in refining, actually. And since that time, I've been exposed to process safety management. At the time, process safety management was one of the strongest HSE type management systems that were around. I've held several different positions in my career in this organization, and I've moved through to becoming HSE director for some time. Then I took over as an executive director, and then now as a senior director for sustainability and operational excellence in ENOC. But I also, as Rahmat said, I am also involved with the Energy Institute. I chair the board here for the Energy Institute, which is a UK-based not-for-profit organization. But here, the Middle East branch, I am chairing that, and I've been doing so since 2008. I have several different qualifications and different interests. Also, my focus has been on different technical and governance and things like that, and various different things. I've published several books, also safety management. These are all available. You can Google these, and I've had the pleasure of co-authoring most of these books with some good practitioners and thinkers from around the world on safety management, reflective learning, operational excellence related books, the 10-step MBA for HSE practitioners, also governance and leadership, and also a book on theology with my father. And the last book, which is coming out inshallah next month or this month, is Process Safety Management and Human Factors. This is with Elsevier, also with the in coordination with the IChemE, the Institution of Chemical Engineers in the UK. So my presentation outline very quickly, and I'll try to go through this very quickly and leave some time for some questions, because I think we have to stop at 4 o'clock. So I'll give just a quick introduction to PSM, and then define human factors as well, because many of us might understand as HSE practitioners PSM, but maybe less of us understand the human factors aspects of things. And we'll go through a discussion of the different elements that we know in PSM and try to bring in where human factors play a role in this. And then I'll come back with some closing thoughts, and then maybe we'll take some questions, inshallah. Of course, this is a huge, vastly big subject. And in fact, if we were to really do a proper training on this, it would take at least, 8 to 10 hours. So what I'm going to be doing is really giving very much a very, very high level taster of the same. But I'll try to also explain some of my personal experience on this. So I didn't write the PSM and Human Factors book. Is not a book that has been written only by myself. I have 14 contributors. 3 of them are, for example, the top 10 human factors specialists in the world. We have people who come from regulator background, come from consultancy background, come from practitioner background, and so on and so forth. So it's a very, very rich kind of book, and gave us different perspectives. I was the chief editor of the book, as I said. So what is process safety management? So if we go back really the 29 CFR 19110, 119, which was published in 92, the process safety management of highly hazardous chemicals, defined 14 elements. These were known as the process safety elements, which today there are different other organizations who have created other process safety management systems, which include more elements. Some companies have also adopted since then a system where there has been more elements. Of course, the PSM OSHA standard is very much a regulation, a prescriptive regulation in the US. However, around the world, people have adopted it as a sort of a best practice, but they were able to modify where they saw that there could be some benefits to their organization, or make it more applicable to their organization. And that's why you will find that there's been many variations of the PSM system. I've had the chance to audit and look at different systems from different companies around, for example, the region and India. And I see always that, sometimes they change the nomenclature of the element, or they add a couple more elements and stuff like that. So, for example, one element, this employee participation or the training, they might change it, like Enoch, we called it training and competency assurance, for example, at one time. Contractors, we talked about contractor safety management, etc. So hot work, some systems called hot work permit, or they just put it all under, sort of PTW or permit to work systems and so on and so forth. So anyway, there's been a development. In the US, obviously, they still have to meet the requirements of the latest OSHA standard. So what is human factors? Human factors can be described as the design of systems, jobs, and organizations to match human capabilities. This is extremely important to understand. So what we are trying to do with human factors is really understand what kind of design we need to have in a system in order that it matches the human capabilities, right? The objective is to optimize the human and system performance. So, a lot of people think that human factors has purely been brought in to actually reduce human error. Yes, I mean, that is one of the things, but actually it is more about the optimization. So you have to look at it in a positive way, that we incorporate the human factors in order to drive very much the optimization of the human and when we say system performance. So human factors is more focused on designing the system to meet the capabilities of humans, rather than try to change the human to meet the demands of poorly designed systems. But I'll come back to that because this is extremely important, because when we look at human factors, many people think that human factors is humans are the cause of all human errors causing all these incidents. But actually, in many cases, a poor design or an substandard design, actually the human beings who are working around that plant actually are the ones who are causing the safety because of the reliability, because they understand the weaknesses in the design itself. So it's not only about humans causing errors, but humans also enhancing the system. Human factor approach is therefore distinct from other approaches. You'll find a lot of people who are talking about BBS, behavioral-based safety, training and competence, and safety cultures and all that. Human factors is a bit more of a science-based approach. There are ways of actually calculating numerically. I teach alongside some professors in the UTP, University of Technology Petronas in Malaysia, the master's program, the MSc in human factors. So I take actually the practical side of things. I co-teach. So the first couple of days are taught by the human factor expert professors who are talking about how you calculate, using different kind of tools and things like that. But I come in and talk about real incidents and then discuss how human factors play the role in reducing the incident, causing the incident in the first place, and reducing the impact of that incident. So again, humans and human factors really have a fundamental role in PSM, and inshallah, I will try very hard to explain that in this presentation today. There's significant advances in PSM today. Things like using different types of tools, HAZOPs, bow ties, and SIL studies, etc., and use of sophisticated kind of technical safeguards that have been put in. But there's also been a good development in industry, but we still see major incidents and accidents are still happening, in both the prevention and the causation. So human beings are really, we believe, is less understood than the technical safety aspect. So because most of the people who are driving and developing these systems were engineers, many of them were not involved in the human sciences, more involved in the sort of technical sciences and engineering and sciences, etc. So human factors, therefore, arguably represents the most important area of focus for future improvements. And I say this, that it actually also, looking at it from a positive point of view, also provides us with the greatest opportunity to manage the challenges of safety. Right? So. Humans are flexible and adaptable component within any PSM system. And we usually use human beings when it is actually too difficult, too complex, or too costly actually to put in automation. So a lot of people think, you put in automation to simplify things, and actually no, you need to have human beings when things are too difficult, too complex, and and too costly to have automation or an engineered safeguard. So you need to have the human being in the end as the overall guardian of the system. So technology and human beings, obviously both focusing on the reliability and adaptability, can then create for us a good PSM system. Yeah. So every PSM system should really look at the reliability of technology and the adaptability of human beings, and together they work together hand in glove, to provide the safety levels that we want. Humans were traditionally seen as the weak link in the PSM chain, and focus on human activity has been really for the last many years. Sorry, 1 second. Rahmat?
Yeah, yes.
Can everyone see my presentation?
Yeah, I can see your presentation. Can you put it in presenter mode? It is,
The problem is when I put it on presenter mode, I have two screens. If I put it onto presentation mode, what generally happens then is it will come off and then I will not be able to share. I'm sorry.
Okay, that's fine. Okay. Yeah, that's fine. We can see
I need to learn more about the technology, Rahmat, Anyway.
That's fine, sir.
All right. So obviously we look at human beings as being traditionally the weakest link. However, in the PSM chain, but the focus on human activity for many years was on eliminating and mitigating the human error. We talk about enhancing the human reliability by understanding human beings and how they interact with the system, and that's where we can unlock value. So humans are essential component of the system, obviously, and enhancing the effectiveness of the flexibility of the system as well, and not only just a source of failure. So if one thing I would like a key takeaway today, please, ladies and gentlemen, is that human beings are not the source of failure. They're the source of actually enhancing the effectiveness of the system. Take most advantage of the skills and capabilities which human beings come with, and it's important to make use of this established kind of HF theory and practice. So let's take, for example, understanding the human failure mode. So this is the very basic, So if you have human failure, for example, that human failure can be caused either by error, which is a cognitive error, or it could be a violation, a motivated error. So someone actually violated the system. So these violations can be routine. They can be situational. For example, routine that people bypass the system all the time. Maybe in certain cases they're situational, that some situation happened, so you went and bypassed the procedure. Or it could be an exceptional, going and opening, for example, a fail-safe valve or something like that. So actually going against the standard. Or it can be malicious as well. Somebody might want to be doing some damage to the plant or to the company. But the cognitive errors, which are usually the case, are either skill-based, and this is a slip of action or a lapse of memory. So, or a mistake, and there's a rule, and you're breaking the rule by mistake because you didn't follow the rules. Or knowledge-based, actually your competency is not there, so you made the mistake because you're not competent and you cannot do this. This is why we find that a lot of young people get injured on both spectrums. So you have the younger people and the older people. The younger people because they have less experience and less knowledge, and the older people because they're more complacent and more too confident sometimes. So you can have this thing. So the rule-based mistake would be more done by the complacency. The knowledge-based would be more based on lack of experience. So this is just understanding human failure modes. This was a few years ago when I was doing my research on leadership and process safety management. This diagram sort of summarizes where you have. So you have the system on the left here, where you have the various PSM elements. You have a PDCA, so you start with the leadership on the top. And for the leaders, and I'll come to talk about leadership now in a minute in a bit more detail, because I think it's extremely important to drive this whole human factor management in process safety management. So leadership qualities, the leadership competencies, the behavioral competencies, even the emotional intelligence in leadership. Of course, understanding corporate governance and the risk management systems as well, and understanding the HSE, everything. And then the policy development and the implementation at the levels of leadership, at the board and at the managing director level and their team. And this creates the planning, which is at the heart of the model. When you have monitoring, and I'll talk a bit about monitoring and KPIs in a minute, when we look at things like audit and inspection, external assessments, and I'll talk a bit about KPIs also. And we have the review, which is the management reports, the annual target setting process, which is linked again to the KPIs, and then you have the system. So leadership is part of an overall process safety management system. So when you look at the attributes, this is taken actually from the IOGP document on shaping the safety culture. They talk about 7 key leadership characteristics. This is based on the work of Krause in 2005. Talked about that leadership should have credibility. Leaders should be consistent in what they do. Sorry, can you please mute? Yeah. Action orientated leaders act to address unsafe conditions. They should have a vision, so they need to paint a picture of safety excellence to the organization, and therefore they must understand, the concept of process safety management and what they're trying to get to, and going really beyond pure compliance. Accountability leaders, they need to ensure employees take accountability for safety critical activities, and they should have a just culture in place. Communication is very important because the way that leaders communicate about safety creates and maintains that safety culture in the organization. And then there should be collaboration, and I'll talk a bit more about collaboration also between practitioners, not only between leaders. We encourage active employee participation. You'll notice I'm involved heavily with the UAE with the ISO 45001 standard, which is obviously not process safety management, more on occupational safety and health standard. But employee participation and consultation is a very, very strong new element of the 45,000. One of the key differences between the ISO 45000 standard and what we used to know as the OSHA's 18001 standard. And finally, feedback and recognition. So, recognition needs to be given soon, certain, and positive to encourage that kind of safe behavior to continue. And, when you do behavioral-based safety, and this is part of human factors as well, you can reinforce behavior by really taking action against those who are not complying and taking good action, positive action against those who are complying and doing good things. So when we come to monitoring and managing PSM performance, as I mentioned earlier, when we talk about sort of KPIs, there's a big discussion about leading and lagging indicators. I didn't go through this. Usually when I talk about leading and lagging indicators, especially when I speak to senior leadership, I always put the bow tie diagram. So on the left-hand side of the bow tie diagram, for those of you who can imagine, that's where you're measuring actually all your leading indicators. And then after the incident, on the right-hand side of the incident of the diagram, you have the lagging indicators. So leading indicators are very predictive indicators, or they should be predictive indicators. Leading indicators also they can be used to reduce reoccurrences of incidents. Lagging indicators also tend to be outcome orientated, so describing already what has occurred, but they have also their own value in trying to understand how you can prevent incidents from reoccurring. So that's why even high potential near misses, some near misses should be always studied. In the aviation industry, when I was doing my research on high reliability organization, I realized actually one of the reasons why aviation industry is so strong is that they actually measure all what we would call a near miss. They call it an incident. Anything which is a near miss, they will call it an incident, and they will study that incident. And that's why their reliability levels are much higher. They're both equally important. They give insightful perspectives. They're very important to giving leaders in organization a snapshot understanding of what's going on. And but they are really, really highly dependent on the target setting methodology and process. So I've seen many KPIs and all of that. They're not really giving an indication because the target setting methodology, the process, the inputs have not been effective. Sorry. So let's talk now about the integration of human factors in the hazard identification and risk assessment. So this is typically one of the elements in process safety management. If we look at this diagram, you start really, and you really want to involve HSE and the HF specialists really at every stage of your project. But really, the earlier you get them involved, the better, because if you are able to change something, for example, in the design at the concept or the feed stage, usually it will cost you about $1. To make that same change, once you've passed the detailed design and you started construction, it costs you $10. If that same change you want to do after post-commissioning, and you've commissioned the plant and now you need to do a modification, it'll cost you maybe $100. This is a rule of thumb, 110, 100. So it's better always to involve really, the people and the specialists really at the earlier stages of the project, in the concept review, the risk assessments, and the risk management at the beginning. There are different types of basic HAZOPs and QRAs which are done at the earlier part of the thing. But once you go into the detailed design, because then in the detailed design, you should start involving people who have operational experience, who have human factor expertise, besides for the design engineers, the instrumentation, safety guys, everybody, right? And then, in the commissioning also, and looking at these kind of things. And I'll discuss briefly PSSR, pre-startup safety review, which is also another critical element of PSM. So what are the main causes of accidents in the chemical process industries? As you can see from this diagram, we can see that there's so many different types of incidents that can happen, and classification of incidents that can happen. However, human and organizational errors, account directly to human and organizational factors, right? So in this diagram, it talks about, 20% of these incidents being human organizational. From my experience of managing incidents or being part of incident investigation teams, many of the incidents you will find will always have a root cause in human lack of performance or error. So I explain one thing. So for example, corrosion. Corrosion management, you should have a corrosion management program. You should have, if you set, the corrosion management program frequencies too far apart, this is actually an error that was made by a human being who is a corrosion expert, who should have known that we should have done the checks every 6 months, not every 12 months or every 18 months. Mechanical failure, even, or even heat transfer, a runaway reaction or something like that. This is, when you go back to the design, maybe something was not designed, wasn't thought about, and the human interaction wasn't thought about carefully enough. So when we look at, how do we manage inherently safer design, we look at, areas, so we have to understand the causation trajectories of incidents, and then we manage the control of such incidents using this effective kind of methodology. So we look at both the risk to humans and from humans, if that makes sense. So we look at the risk to humans because, human beings are actually what we are trying to preserve. Preservation of human life is extremely important. But we also look at the risk from humans. So what humans can actually cause error. So if this error is, made, is it going to be a catastrophic, kind of error? So in the nuclear industry, for example, even if a person makes an error, it will not lead to a catastrophic incident because there's so many layers of protection that even if 2-3 people make errors in a row, it will still not cause that kind of level of catastrophic loss. So we have principles which are called the minimization, the substitution, the moderate way of actually looking at the hazards, and using for example dilution, refrigeration, using process alternatives, and then there's also the simplification. Sometimes to reduce the complexity in a particular thing, maybe you don't need that level of complexity for a particular process. You reduce the complexity in the design and you make it easier and less complex, less things, less complex, less problems. Another very important aspect of process safety management is asset integrity. I have only one slide on this, and if anything that we need to understand about asset integrity and process safety management, human factors, is this, that there is a fine balance between these 3 areas. So we have a design integrity, which is the engineering of the plant or the facility or the process. There is an interaction between that design, yeah, and the inherently safer design, for example, etc., and the design integrity with the actual operational integrity. So, for example, I have a car. I buy a very sophisticated car, and then I don't drive it in the right way. I don't drive it in the right way like it was supposed to be designed. So definitely the car, something will go wrong with it eventually. If I don't maintain the car, right, and I don't do a proper asset mechanical integrity management of the car, then also something will go wrong, right? So if I don't operate it properly, if I didn't design it properly in the first place, if I don't operate it properly as I should operate it, and if I don't maintain it properly, all this can lead to a process safety problem, yeah? So, but at the heart of this is this HR integrity. Now, some systems will call it HR integrity. Some of them call it just put leadership in the heart of, in the center of this. I say that it's actually human reliability and integrity, which is at the heart of this. When you have the human reliability, the integrity, and obviously the leadership, then the design integrity, operation integrity, and asset mechanical integrity, if they work together, you get much better asset integrity. So moving then to, I think, one of the most important factors in PSM. So when people ask me about PSM, I tell them that management of change is, if not the most important, single element of. Because if you look at, if you look back even at the Flixborough disaster in the 1970s, and even the Piper Alpha, for example, disaster, all of these, you go back to management of change, yeah? So it's one of the most fundamental elements. Most incidents in industry occur during either the changing phase. So either if you're starting up or shutting down, yeah? So when a change is introduced, running system designed to operate in a certain way. But then what we do, what we decide to do, we change the operating envelope, and now we redesign it and redefine it to operate in another fashion, right? So the procedures must really ensure that these considerations take place. First of all, when you do any change, first of all, you have to understand what is the technical basis for the proposed change. Then what is the impact of this change on safety and health, right? Obviously, if you're doing that change, you need to know what are the modifications to your operating procedures. And then it's not about only changing the procedure, it's about communicating the procedure, making sure people are trained on the new procedure and take over, even if it is a temporary change. Sometimes, we are only doing a change for 2-3 months, but still, you still have to change and do a temporary operating procedure. People need to be communicated with, and everybody needs to be trained, and we have to make assurance that everybody understands what's going on. And of course, very important that the authorization requirements for that proposed change are met with. So in management of change process, I don't have too much time to go into this, but we have, even in my experience, had many debates with all my colleagues in HSE that should a management system review be what we call sequential, or should it be done in parallel? So the parallel one is the, sorry? Hello?
No, you can continue, sir. I think there was something.
Okay. So you have the sequential and you have the parallel. In the parallel, the MOC originator develops the detailed proposal and routes it concurrently to all the parties of interest, right? And then they sit down together and they go through it. On the sequential method, the MOC originator develops the detailed proposal, then he sends it in the process engineer, the control and instrumentation operation site. The review of the operations site owner, the review of the inspection and the maintenance, and the engineer or the designer, right? And then to the vice engineer. The problem there is obviously, you don't get that level of discussion between them. And in our view, I think you should do it probably in probably a sequential way. But you can do it in parallel for more simpler modifications, but more complex modifications, perhaps a sequential longer process needs to take place. Of course, when you're doing the change in parallel, it's a bit of a faster review, but it doesn't generally give you that same level of fidelity that you need. So when we talk about safe work systems, so that was management of change. When we talk about implementation of safe work systems, where does the human elements really come into this? Is that, we have to start with the risk assessment, the job safety task analysis, or the JSA, as they say, assess the task, really look at all the aspects of the task, identify the hazards, and try to eliminate or reduce the risk using the hierarchy of controls, and then risk rank. And then define the safe methods that you need. And then when you do that, you have to produce the procedures, and then you have to specify and sequence the safe methods of doing this. And then there is the implementation of the system. So you have to communicate, as I said, train, and avoid any shortcuts, and provide a stop work program for people who might bypass the procedure. However, one of the things that I found is very, very good with certain organizations is between defining the safe methods and implementing the system and the procedures, is that we walk down the procedures with the operators. So we actually go through step by step the operation because then you ensure that the human that's going to actually be conducting the task is very much aware of what they need to do, and then monitor the system. Obviously, make sure that people are operationally disciplined and following the system. When we look at ineffective work, just so we can understand a bit more about the human factor aspects of it. So an operator is given an activity or a performance. If they're not given an overall work plan, what will end up happening is that they will be confused. And if they're confused, they could make a mistake. If they're not given the right amount of resources, they will get frustrated. And if they get frustrated, they can make also mistakes. Sometimes if the resources are also not critical, then they will not have they will not do the job properly because they don't have the right kind of resources. If the work is not clear and the roles and responsibilities are not clarified to them, you might get resistance, and then you might have different people doing different things, assuming that different people are supposed to be doing the same thing, and then you can have real confusion, and that could lead to incidents as well. And if they don't have the right kind of skills and system, as I mentioned before, they will have anxiety because they will not be able to, and they will make mistakes. They will make maybe sometimes really cardinal mistakes. So it's important that when we're designing our effective work practices and procedures, that we consider all these things when we come to implement. We come to another very important aspect of process safety management, which is called PSI, Process Safety Information. This is when, and it's a very important part of process safety management. And from my experience with working with a lot of HSE people, this is not fully appreciated always, because we're always assuming that the data and the information is always available, it's always updated. So you can have many, many things that can go wrong. I just put here on the PSI, human errors for PSI are, can usually occur because of this. The information, for example, for certain substances or chemicals is not available. Manual entries are incorrect, and they were communicated the wrong information. The person who's entering the data into the system has no expertise about these chemicals, so is not giving the right consideration. Users are actually not aware of the particular chemical hazards and the availability of the information in the PSI. There are many, when I've been working, we have received sometimes shipments of certain products, and the MSDS sheet is either incomplete or not available, or the wrong material, etc. Change in chemicals, the required concentrations are not updated as well. And this is really important, especially when you look at the industrial hygiene data and you're looking at the latest, MELs and OEL levels of working with these chemicals. Responsible persons also have to trust themselves about memorizing the changes. Responsible person has to update the PSI and responds too late and to provide this information, or the work instructions or the procedures are not being updated. So many things can go wrong when you talk about process safety information. Also, for a process equipment, sometimes we find that the detailed information on the process equipment, for example, the standard data sheets are not available, right? The maintenance record has not been updated. And then people are just relying on their memory that, oh, did we maintain this equipment? Did we change this particular valve? Did we do this? Did we do that? the equipment inspection plan is missing sometimes. And this we find during the pre-startup safety review, the contractor is not passing on all the documents. And there's so much documents which are being passed on by, from the contractor party and the feed contractors, the EPC contractors, and there's not enough time for all the engineers to actually check if all the information has been passed on. Workers' training data is not updated on the system, or the specification sheets for the process equipment, are not available. So you're having to really navigate a little bit blind. Process technology component also. The human factors here can be the relevant diagram, the PNIDs or PFDs, layout diagrams are not accessible or not updated properly. And I've seen this. I've seen many issued for construction drawings being issued immediately as issued for as-built drawings, and the as-built and the issued for construction drawings are different, because during the construction some changes were taking place, but the contractor sometimes doesn't update that drawing. He just copy pastes the issued for construction drawing. Work instruction procedures are not up to date. Information for handling, for example, emergencies has not been provided, and workers' training and behavior audit is not today. So many things can go wrong, and that's why I just wanted to mention the PSI. I would just mention this, although this is really important. This is as important as management of change, I think. Collaboration between, the engineers, the contractors, the operational teams during the pre-startup safety reviews is so important. I think that the most successful projects I've seen who have done good PSSRs have been when there's been good collaboration generally throughout the project between these teams. Not the engineering team is trying to throw the problems or just hand over the baby to the operations guys and just they deal with it. No. There are many levels of reviews, and trust between different teams is very, very important, and the competency and the trust that these people are knowing what they're doing and what they're supposed to do. It's a very, very critical operation. As I mentioned earlier, in management of change, most incidents occur during startups and abnormal conditions. That's why, during modifications and stuff like that, when you come to do a startup, that's the chance that, something can go wrong. I asked pilots. They tell me the first 5 minutes and the first 5 to 10 minutes and the last 5 to 10 minutes of any aircraft journey is the most critical and the most unsafe. And that's why you see that level of control and level of discipline which is required when you're taking off and landing. Human factors and interactions are very critical to understand, and communication systems are very, very key, in high reliability and resilience organizations. And then you need pre-startup checks and tests to be done. And as I mentioned, the PSI needs to be communicated in a very effective way. Again, I've already spoken about this earlier with regards to projects, but when we look at really understanding human factors reviews, the first diagram that I showed you of projects was more, actually it was drafted by a practitioner who has nearly 40 years of experience in projects. Now we're talking about just looking at the human factors on the project. So in the feasibility stage, in the concept, defining the human factors input that's required for the project at the concept phase. Very few, ladies and gentlemen, I can assure you that very few companies, they're doing this, right? Very few organizations are doing this. At the detailed design and the construction, you need to have, that good, human factors elements taking place. And as you go from the transition to operations, so an understanding that as the engineers and the contractors are now passing on to the operations, and the human factors risks have to be managed very, very well in the operations, and probably between construction operation at the pre-startup safety reviews. And even in decommissioning or shutting down, managing human factors risks for disposal of asset or shutting down the asset is very, very critical. Lastly, and this is, as I said, this is really a science. Human factors is in itself a massive science. Even there are different types of specialists within the human factors kind of a working world. But there's three very important things that are important in the, when doing safety critical task analysis, SCATA. which practices usually this practice comes in 3 stages when you're looking at a particular operation. One of them is the safety critical task identification, so just hazard identification effectively. Then the task analysis, where you have to actually understand what is involved in the task, and then the human reliability assessment on that task. So we use the initial part, the identification part, to rank the order of tasks in terms of their safety criticality and their potential to lead to a major incident. Then we look at the various methods of performing this identification. Then the high priority safety critical tasks, individually are analyzed, and then the detail is we determine how these tasks should be undertaken. Then the tasks within the analysis subjected to this, hazard human reliability assessment, which involves also other subtasks like performing the shaping factors that could make error more likely. So I showed you initially that chart where, how can people understanding how human failure analysis. So you work backwards. You look at this kind of thing, and you look at what are the antecedents that can cause people to perform or behave in a particular way. How the error or the violation could occur, also understanding and doing an error assessment. And then looking at the consequence of that failure. So if there is a failure, if there is another safeguard or not, and how the failure could be recovered. So even if there is a failure, what is the recovery, what is the incident, what is the impact, the risk controls which are in place. And then that leads us to doing, if there is any residual risk, as when we do the risk assessments, we do any additional risk controls. Okay. So I would like to now close my presentation. These are just some parting thoughts. I'm sorry, this is as I told you, is a huge subject which I'm trying to compress into 45 minutes. Understanding the PSM elements is very key to the future of the industry, right? And understanding how these may change. Also understanding that these elements, have to be understood in the context of the human factors, as I explained. I believe that the human factors impact on all the PSM elements, and I try to demonstrate that in a few examples today. These elements also, they require many branches and expertise. So different elements should be appreciated in the industry. There are different generalists and specialists. I consider myself a generalist. Maybe I'm not a specialist in any particular area, but I probably know more about certain aspects than others. So having and creating a good team of balanced people between the generalists and specialists is very important. And then the key is collaboration. And then there are many standards around the world. Today there are many standards around the world, but the ability to really understand the impact of addressing risks when using any PSM systems is very important in a very pragmatic way. It doesn't matter what system you're using. All of the systems are the same. They've got different names and whatever, but they are ultimately trying to achieve the same thing. The PSM and the human factors specialists come from very different thinking paradigms. Some of them are industrial hygienists, industrial psychologists or occupational psychologists, guys who are coming from, the humanities, etc., doing, a lot of stuff on human factors. Whereas a lot of the PSM or the hardcore PSM guys are engineers, chemical engineers or mechanical engineers and EHS engineers who are trying to. So they have different education backgrounds, they have different experiences, and they have different thought perspectives. So really, they have to work very much together and collaborate to understand each other and understand, so the engineers have to explain how the system works, and the human factors guys have to explain to them how the human being will interact with the system that has been introduced to them. And PSM cannot succeed to provide a high reliable organizations without a good handle on human factors in the industry. That is why, ladies and gentlemen, even though PSM has been around now, PSM systems have been around from 90s or even earlier than that in other forms, yet at the same time, we are still seeing major incidents happening around the world. The system will not get rid of things. Engineering controls will not get rid of things. Human factors alone will not get rid of things. All of this has to work in a collaborative way. Okay, so ladies and gentlemen, that concludes my presentation, and we are happy now to take some questions. I think we have 10 minutes. 10 minutes to take some questions, if you like.
Yeah. I think you can unmute and you can ask questions right away.
Okay.
Or if you want, you can. Yes, Mr. Peter. Yes,
hello.
Peter.
How are you? Good.
Good.
Hello,
Yeah.
yes. Yes.
Hi there, Doctor. I'm particularly interested in how you link, say, failure mode effect analysis or any incident analysis system to your human factors at the start of a project. So when you're measuring the performance and looking at where the human factor failures are, do you use a particular analysis methodology such as failure mode effect analysis or another system?
Yes, there are different types of systems. As I mentioned, where I teach at UTP, there are some specialists over there who are the human factor specialists, and they use different types of tools. One of them is called HEARTS. There's different types of mathematical systems where they have certain factors, right, loading factors, and then they say, okay, look, if you have an operator who has to operate a certain valve so many times a day, and then there's ratios where you add them. So if he's doing that job alone, if he's doing that job in the middle of the night, if he's doing that job in darkness, if he's doing that job, and then these factors are added, and then you multiply these factors, and it then actually gives you a different factor of the failure mode analysis. Yes, I mean, to answer your question very quickly, yes, there are methods of doing this. I'm not an expert in that area. There are human factor experts who actually teach this.
Right. Thank you very much. Excellent presentation. Thank you.
Thank you. Thank you very much for your question. Yes, anyone else?
Hi, how are you? This is
So could you speak up, please?
Yeah, actually, I just would like to understand how the PSM element can be associated with the psychosocial or psychological hazard at workplace. Means, is there any kind of model or kind of percentages set that how much psychosocial or psychological hazard contribute to process safety management events?
Not directly, as I just mentioned to your previous colleague who just asked the question. There are ways of actually there's actually ways of measuring the human reliability side, and it links to the psychosocial. So how a person concentrates if they're working at night, or they're working in night shift, or they're working in darkness, or they're working in a very monotonous, boring job. There are ways of calculating that. However, the ISO 45001 main TC283 committee, ISO committee on, they have actually just released a draft of the ISO 45003, which is the psychosocial risk. And what they are doing is actually they're looking at wellness, stress, and I'm sure that standard is going to go through some major changes because of COVID-19. But they've actually come up with a standard to try to put in prevention methods, mainly based on qualitative thinking, with regards to that if people are stressed, they error levels, they will go up more and more. And how do you manage that in facilities is, I think, the best way is to train the supervisors, to understand when people are going through certain stress. The HSE people need to work with HR type people to understand what is creating greater stress for people at work, and trying to understand what are the actual stresses, if they're physical or psychological stresses and stuff like that. So a collaborative method needs to be approached by the management team to try to assess what can cause greater stress in the workplace. I hope that answers the question.
Yes, thank you. Thanks.
Yes. Thank you, sir.
Good evening, Dr. Vada. It's a very excellent presentation from your side.
Thank you.
Very fascinated by your compressed version, but still it covers overall. This is Dr. Ramesh with you. My question is, we recently start hearing human engineering in many of the organizations. So the human engineering is something related to the human factors development, or how that can be linked to our process safety performance improvements.
Yeah, I mean, human human engineering in the context of human factors is understanding understanding behaviors and understanding what are the antecedents that cause certain behaviors, and then based on those behaviors, what kind of consequences you're going to get. So there have been a lot of studies about, for example, operators operating in a particular way, and then when you change certain conditions, how they're going to, because typically human beings will behave in a particular way. You can address that by putting in, for example, rules, regulations, governance, and getting them to do certain things. But at the end of the day, their level of compliance is very highly dependent on many factors, so social factors. So for example, today, people walk around with masks, yeah? They walk around with a mask. I mean, some of them are convinced that they wear a mask and they want to wear the mask. Some others really don't want to wear the mask. Some of them don't wear the mask properly, but they just walk around with the mask, just hanging off their necks. The level of sort of compliance, to get that kind of level of compliance within sort of the workforce. Usually, if you really are able to convince people, today people are not all convinced. Some people tell you, no, wearing a mask all the time is not good because I'm not breathing properly. I'm breathing in carbon dioxide. Others are telling you, no, we should wear a mask because it's, it protects us at the end of the day. Some people will tell you it's situational. I want to wear a mask because I'm going in between a crowded people, then I will wear a mask. Or I'm going to a closed space, right? So there are different compliance. So yes, so you can engineer human behavior. I mean, I don't like using the word of engineering human behavior because it has a negative connotation, right? That you're actually re-engineering and you're kind of manipulating human behavior. But that is the truth. That is the truth. When we put in these procedures, when we put in disciplinary actions, when we put in rules and regulations, we are actually engineering behavior of people. I hope that answers the question.
Yeah, sure. Thank you, Dr. Wada.
Mr. Ali.
Hi, Dr. Wada. How are you? My name is Ali Radalawati. I'm from the Petrogas. In fact, I have two questions. One is quick. When you're saying that there is a 14 elements, and I agree with that, the best model I've seen, OSHA, is the 14, which was the start of the process safety management. You know that each element has a view from the human aspect, like employee involvement, there's a human factor, training, everything, each element. Do you think it is wise to put one sort of a third party or within the company, some people who are looking only from that aspect on all the elements? This is one question. The other question is, from my job, we have a number of companies and we try to implement the process safety management. We are successful to some extent. The only difficulty we are finding that the elements which has been described by OSHA or anywhere, most of the systems do exist. Like the hazard analysis, you have a risk management system in the company. The process safety information, you have the libraries of the documents. Training, you have HR department who's looking after the. So each element, there is in fact something in the company. All what we try to do is link them together. What would be the best approach in order not to recreate the wheel from the start?
Okay, it's a very good question. Thank you, Mr. Ali. But both questions are very important. On the first one, I mentioned to you that you have generalists and specialists. So what you should do is, you can't really have a process safety management expert in all areas. Then there are management system experts. So you have people who are HSE people who can be process safety management experts. Some people from operations can be that. I have found, and a lot of my colleagues who are HSE people might not like what I'm saying. I have found when I've done competency-based interviews that guys who are coming from operations usually are better in PSM than HSE people. HSE people are very systems guys. The PSM people have got a lot more operational sense, and they can really understand the implementation of PSM in a very effective way. So you have the generalist, and then you have the specialist. Then you have some real specialists in, for example, guys who are management of change guys, or guys who have done a lot of stuff on process safety, or the guys who are really very good at permit to work systems. So so some of these require also particular PSI guides, for example. When we did the book, actually the guys who did the PSI chapter in this book are two big academics. Yeah, they've worked with many companies, including Petronas, on developing PSI systems. That takes us to the next point about sharing information and being able to share the information. Sharing information there's 2 or 3 problems, and I mentioned that in the PSI slides. The information is not up to date, or the information is missing, yeah, or the information was never put in the system in the first place. So there are different modes of failure. So maybe the information was not put into the system in the first place. That was really at the inception phase of the project, because everybody was busy trying to commission the project. But if you have a common system, if you have a very strong, IT platform, yeah, that can connect all the systems together. I mean, SAP, for example, or Oracle, or whatever, where there is one view of the truth. Yeah, there is one truth out there which connects the HR systems to each other. It connects all the and with certain ability to access information which is being loaded. So, for example, if you're looking at health data or employee absenteeism data, the HR people are managing that system. They're the owners of that data, but the data is being entered into the system. The HSE guy can download that data, and he can then try to analyze why people are taking. Is it because of musculoskeletal issues that they're taking sick leave, or is it because of flu, or is it because of injuries, etc. Right? So you need to have a very strong, I think, good connected IT system. There's a lot of very good IT systems out there. If you speak to Mr. Rahmat, he's an expert in this area. I'm not really an expert in this area about how IT systems, and you have these kind of IT operational systems.
Yeah, I think we have seen a lot of technology side where all the MOCs and the PSSR play a very critical role in terms of operations. And there are a lot of technology has helped in terms of taking approvals, having documents in place, having all the risk assessments information in one place, in terms of cost, in terms of approvals, in regard to commercials, everything system automates, and it helps in managing and see that all the activities done in a very less time frame. Yeah.
Yes. Anyway, it is 4 o'clock, Rahmat. We are just in time. Sorry about the delay. We started just a few minutes later. Unless there's any other questions, we can maybe close this. I think if there is interest from those who have registered today, and you like this presentation, and you like, I can try to, in the next couple of weeks, maybe do another webinar and particularly talk about any particular area of interest that you guys have. Just communicate, please, with the organizers, and inshallah we can participate again and share some information. But you can guide us on what the majority of people would like to have a presentation on. Okay, Mr. Rahmat, over to you, my friend.
Yep. Yeah. So firstly, thank you everyone, and to be spend your valuable time for this session. And Doctor, firstly, thank you very much for giving us an insights on PSM and the human factors. I never thought human factors could play such a critical role in the process safety activities. It was a lot of lessons learned today for me. So what I'll do is I've already recorded these sessions. I'll be sharing this recorded session with all the attendees. And if any information or any questions or clarifications are there, you can write back to us, or if you need any information, write back to us so that we can share the required details. Yep. So
thank you. Yes, and Rahmat, thank you very much for organizing this as well. Let's not forget to thank you also for all the hard work in advertising this event and organizing it. So thank you very much. Allah Hafiz, inshallah. Okay, and salam alaikum, everyone. Thank you.
Thanks. Good afternoon. Thank you. Bye.